Morning, everyone. So we're going to take you back in time, take you back 50 years. We're going to explore what the computing world was like in 1969. That, of course, was the year that the first humans landed on the moon. It was the year that the Boeing 747 was introduced, and it was the year that Woodstock, the rock concert, happened. So let me introduce our panelists. First, Vint Cerf was a graduate student at UCLA. You're going to hear that a bunch. See? He had met Steve Crocker, who's our second panelist, while they were at Van Nuys High School. Steve was both an undergraduate and a graduate student at UCLA. Len Kleinrock was, of course, a professor at UCLA, working on computer networking. Wow. Charley Kline was also a graduate student at UCLA. And Bill Duvall was a young programmer at SRI up in Menlo Park, working in Doug Engelbart's Augmentation Research Center. He left UC Berkeley after taking all of their computer science courses. So, Charley, why don't we start with you? How did you end up writing software for this machine?
Well, I had gone to UCLA as an undergrad, and I'd already learned to do some programming from my dad. So I ended up...
Oh, okay, I'll be in the little height.
Go ahead.
So I ended up having to take a programming class and went to the department chair and said, do I really need to take this? And he said, no, you don't need to. Why don't you work on my research project? So I was working for Jerry Estrin on the research, and then Len got this project to work on the ARPANET. And most of us switched over to Len's project. And I was working on trying to keep our computer system working and working on the operating system, and then when the IMP came, I had to write some software to make it work.
And you were building an operating system mostly, though, right? For something called the Sigma 7.
Right.
Okay. And how did you end up being on campus at 10:30 tonight 50 years ago?
I enjoyed programming. I sort of describe it as when you got a programming working, it's like moving up the next level in a video game. You got a little excitement. So I would often stay late at night. Sometimes I stayed all night and programmed all night and then went to my classes in the morning.
Okay, so the first connection that you had with Menlo Park was not seen as a big deal by you?
Not to me.
And why did you pick October 29th, 1969 to do it on?
I'm not sure there was any specific reason for that date. We were ready to try it. Bill was ready to try it, and we started trying it.
Bill, how did you come to be on the other end of that communication?
How did I come to the...
Be on the other end of that communication?
Well, basically I was working with, at SRI with Doug Engelbart and his group, and that's where a lot of the paradigm that we see today on the internet came from. The idea of using a computer, which up to that point had been used for basically databases for bank and for numerical processing. The idea of using it as a page-oriented with a mouse information system. And in fact, that's where he invented the mouse as part of that whole effort. But part of the concept was that there would be basically a lot of workstations, or workstation, he called them knowledge centers, basically. And these would all have these types of terminals, and they'd be connected by a network. And so when the idea of the ARPA, and it was being funded by ARPA, so when the idea of a network came along, it was a very natural step to say, we'll be one of the first nodes.
You and Charley hadn't physically met?
No, in fact, we never physically met until I think 10 years ago or 15 years ago.
Yeah.
So,
but you did regularly talk on the phone.
We did talk on the phone. When the IMP was delivered, which was I think the beginning of October at SRI, along with the IMP came a deadline, and the deadline was October 31st to basically have a login from one computer to another over the ARPANET at that point, and so we worked furiously to try and get all the software ready to do that. And in order to get, we knew that everything was, I mean, there were a lot of things that we were putting together. It was a complicated system, a lot of pieces. And so we decided to start testing early. And that's why it was October 29th, to see if we could beat the deadline. And so we scheduled a test for 29th. It was at 10 o'clock at night because there were other people that used the system during the day. And we knew that it was fragile, to say the least. This was pre-alpha stuff.
Okay. Now, but also, this wasn't your primary job at the Augmentation Research Center. This was something you were sort of called in at the last moment to do?
That's right. Yeah, there was a person had been contracted to do the interface, and when the imp was delivered, doing a review of the state of the software, it was obvious that it wasn't going to get there. And at that time, I was the only person in the group that both understood the protocols and could work in the STS 940 time-sharing system. So I sort of, I was volunteered, let's put it that way. And
so this was the Watson come here quick moment of the internet, and nobody really knew that was the case for maybe a decade or two. Is that right?
I'm sorry.
This was the Watson come here quick moment for the internet, except that came much later.
Yes, that did come later, but it was
actually, and also, even though we talk about messages, it wasn't email communication. The first phrase that you guys were dealing with was login. And what were you logging into?
Well, Charlie was logging into the STS 940. Basically, so UCLA was logging into the time-sharing system at SRI.
And that was called the online system, is that right, or NLS?
NLS ran on the STS 940 time-sharing system. So it was basically a subpart of that system. And the initial login was simply as a user, later to be an NLS user.
So you hadn't even gotten to the application layer yet.
Yeah, exactly.
Well, so then let's talk a little bit about how this came to be. Steve, there was this process called request for comment. And I think that if you could explain that and how that came to be, because that was really where the architecture for the system came from.
We, the basic plan for the ARPANET had been laid out by the adults. We were the kids. So the IMP was designed by Bolt, Brannick, and Newman, and the long lines, the telephone lines that were procured from AT&T. And then what seemed, in a way, an afterthought was, okay, got to get some software running on the hosts to talk to each other. There was a meeting called at Santa Barbara, UCSB. Elmer Shapiro from the SRI group chaired the meeting. Vint and I drove up. We were. Did you make the choice to send us up there? Somebody said.
I wanted to go the cheapest way. You kept busting my budget.
That came later. The trip to Santa Barbara was cheap. The expenses grew after that. So Vint and I grew up. This was August '68. So this was more than a year before the time that we're talking about. The contract for the IMPS had not yet been let, but it was in process. We met counterparts from the other groups. Bill, were you at that meeting? Jeff Rulifson was there, I remember.
Yeah, I was there. Yeah, it was Jeff Rulifson, Eric Harsland, Elmer Shapiro,
and it was a pretty interesting meeting in that there was not much of an agenda. We all came to find out what was going on, and it was sort of like a cocktail party engagement where you instantly click with certain people that you can tell you're on the same wavelength. And we could see that this communication was going to be more interesting than just logging into a remote machine or sending a file. Those were obvious. We obviously wanted to be able to do that. But we could see a bigger picture. And we kind of self-organized after that and decided that we would keep talking. And in the process of keep talking, we said, well, we should visit each other's laboratories, which is where Len's comment about busting his travel budget came from. And we understood the irony right at the very instant that we said that this network was supposed to make it possible to collaborate at a distance without having to travel. And the first thing we did was lay out a whole travel schedule so we could visit each other's laboratories. Those meetings were we engaged in large and small topics. The specification for the fine-grained communication had not yet been specified because BBN was not yet working on this and they hadn't published their interface specification. So we looked at sort of the bigger picture. What kinds of things would you want to do? We sketched out a number of interesting ideas. And we did this just sitting around a table in these occasional meetings every 6 weeks or 8 weeks. And then in the spring of 1969, so about 6 months before the date we're talking about here, we said, well, we should start writing down some of these ideas. After all, we're supposed to be academics and we're supposed to be, doing research, so we should write something down. So we dealt out assignments to each of ours. You write this, I'll write this. And then I casually offered that I would organize the notes, which I didn't think about it at the moment, but over the next couple of weeks, every time I sat down to write what should have been a trivial administrative clerical note, I found myself balking big time. I had trepidation, and I realized what it was that the act of writing these down might make it look like these were official, important, authorized, and I was very fearful that some adult was going to come from the East. I didn't know whether it'd be from Boston or from Washington, but who are you guys, and who gave you authority to do any of this?
Let me quote from RFC 1. You wrote, "Very little of what is here is firm, and reactions are expected."
That's right. That's right.
Yeah.
So late one evening when I was determined I had to write something down, I said, look, these things have no status, no authority. Write anything you want. Write as little as you have in mind. You can write questions without answers and so forth. Bill had suggested the term request for comments. I hadn't remembered that until recently, but it stuck in my mind. And I said, just as a matter of form, we will make every one of these notes called a request for comments. I figured it was a temporary hack, last maybe 6 months, until there was formal documentation of this network. We numbered, the other rule that I put down was that you had to write it before I give you a number, because I didn't want a lot of holes in the sequence. And so that seemed to work pretty well, except that it didn't stop. It just kept going and going and going, and when I was asked, we did an index of the first 100, and then when I was asked to write something for the first 1,000, I thought this is a sorcerer's apprentice kind of situation where you can't turn it off.
So
There are about 8,800 RFCs
today.
Well, and they're not the same, because in the early days we had no other way of communicating. We sent these out by snail mail, by U.S. postage. We had a mailing list, and in fact, the mailing list was maintained as one of these RFCs, and every time we added somebody to the mailing list, it was another RFC.
Bill remembered that you guys flipped the coin to see who would write 1 and 2. Is that your memory?
I lost. I got RFC 1.
I remember it the other way. You won and got off.
What was remarkable to me about RFC 1 is it was about 2 experiments. Did you guys know much about the online system when you actually set that up?
We had visited, this process from August 68 to spring of 69, we had now visited each of the laboratories. What was remarkable, particularly in retrospect, was the SRI laboratory, Engelbart's lab, they had invented the mouse, and ordinary people didn't see it for another 30 years or something like that,
yeah.
Approximately. And a graphics interface with hyperlinks and structured text and everything. So the future was sitting right there. And better yet, it wasn't just you could take a tour and see it in the laboratory. That group was using it every day. That was part of their basic thing. And so it just had to wait till it became commercially viable. But we were living, at least thinking, in a mode of this is the way the world is going to be, and we're going to lace it together with this ARPANET. And how could we make it flexible enough so that it can accommodate the future technologies that were coming along?
I want to ask a little bit about the culture of those laboratories at the time that you guys were doing this work. You guys both started early, Steve and Vint. You started as high school students spending regular time on the UCLA campus, is that right?
Oh, yes.
breaking in even on occasion.
I was afraid you were going there.
Oh, no, wait a minute. Steve got permission from Mike Markoff, who was chairman of the department at the time, to use the Bendix G15 paper tape-based machine at UCLA, and I think eventually we got to use the 7090. So we had permission, but one evening we showed up, or maybe it was a weekend, we showed up, and the door was locked. And so what happened then, Steve?
So, statute of limitations is passed. Vint and I had been playing with some silly equations and decided we would try to explore them numerically. At least sounds better now than whatever I was able to say. So this Bendix G15 was in a building that called Engineering 1, which I believe is now gone. But I did have permission to use it, and we arranged to come over from Van Nuys High School in San Fernando Valley. It took a little less time to do than it would take today, I think.
The dean is in the audience.
Tell everybody. So we came over on a Saturday, and the building was locked, and I was crestfallen. Two of us are standing there staring at the door, and Vint notices that the second floor window is open. It's one of these crank things. And I'm thinking, we're not really going to. Next thing I know, he's on my shoulders.
I always have, that was the beginning.
He goes through the window, he comes around to the main door, pushes the bar open. We taped the door so that we could get in and out easily during the day to go buy some food at lunchtime or whatever. Nobody else was around. The interior doors were all open in the office. This is long before student demonstrations and all other kinds of things that have beset us. And we worked all day, and we cleaned up afterwards, and we went home. That was spring of '61. 11 years later, in '72, I'm working for the Defense Department. I've got a top secret clearance, and the Watergate burglars break in, and they tape the door. And the guard, who's one of their cohorts, who's in the hotel across the street, is on lookout, but he doesn't recognize the threat because the security guard who found it was in plain clothes. And the shiver that went down my spine was something.
So,
Go
ahead. You can tell your story.
I was at the White House in 1999. Hillary Clinton was doing her Millennium Evenings, Honor the Past and Imagine the Future. And she told that story.
Yeah.
So the question is, how the hell did she find out about that?
I didn't.
It was on the internet. So Stephen Levy has written a book called Hackers. You know that the term hacker meant one thing before it meant something else. And when you guys were first computing in the 60s, a hacker was someone who was really sort of obsessed with computing. And there was a laboratory at MIT, the AI lab, where this culture grew up. Would you call the culture you guys were created both at Menlo Park and LA similar? Was it a hacker culture in that first sense of shared information?
Well, it was MIT that adopted that term. You were there.
I was there, but there was an interesting story. These guys, again, are guilty. There was some guy on campus that committed some terrible break-in to a computer system. They decided to hire him as a programmer. I mean, smart guy. You fired him a few months later, right? Didn't work out.
It was a question as to whether he could learn to do something other than breaking into systems, particularly if we said, look, it's not interesting. We'll give you the keys to everything and see if you can do something constructive. And
so a hack was a really cool piece of software. And a hacker was somebody who produced really clever code. And that was an honorable title for many years.
Yeah. Bill, was the culture the same in Menlo Park?
No, I wouldn't say it was at all. It was, the culture in Doug Engelbart's group, the one that I was in, was basically almost self-contained, and people were very focused on this one vision that we were working on. And although there was some connection to the outside and interchange, it was very little. The group was in and of itself was a little bit odd, and for SRI it was generally disliked, I guess I would say. It was certainly not understood. I mean, they did things like, we'd work at all hours, and we'd have Friday afternoons would be for wine and beer, and you know, this was very un-SRI-ish. And one of the things I remember is when I was interviewing to join the group, the last interview had to be with the head of the engineering department. And you know, he sort of asked a few questions. Why do you want to do this? And I was saying, you know, what they're doing that's the future. That's what, you know, I want to be with that. And after a while, he sort of thought about it, and he looked over his desk at me, and he said, "Son, you don't think what they're doing up there is science, do you?"
John, you know, you're talking about the culture of the period, and there is a very strong component that mattered and helped create what we have today. And it's the way in which the funding took place. I think you're familiar with the story, the way ARPA funded the various centers, the universities, and this. They would go to a great researcher there and say, here's a pile of money. Go do something great. Shoot for the moon. Failure's okay. Go high. Keep going. You have the money for a long time, and we're not going to watch you. Now, what else could you ask for? It was an environment that just generated creativity. It was a golden era. And when that came to a principal investigator, passed it off to these guys, same idea. They complained we didn't supervise them. I said, go do it.
Yeah.
Eventually, you know, if you want something, come back to us. And they ran with it. You just hear the stories, the way they organized themselves and created this community across many universities was a very important component that gave a lift to this whole project.
Well, and how quickly did that end? And was it the Proxmire amendment that ended that era of...
Not totally, but it hurt a lot. They said basically it has to have a military application, has to be competitive. You know, you go to a guy, here's the money, that's not competitive. It's not peer-to-peer, but it worked.
Okay.
Well, on the other hand, ARPA has some pretty smart people. And so they created this thing called a broad area announcement, which said this is the area in which we would like to explore. Would you like to submit proposals for that? I think we managed to induce the right people to submit the right proposals, and the longevity of support from both NSF and DARPA is countable in decades. And so that's still true today.
It's true. But your point about having really good people at the government deciding where the money should go, people like these two here, they were at ARPA, that level of capability, looking out and finding the projects to support. That whole thing worked so well.
I want to ask about the design of the network, but before I go there, you know, a lot has been made of the first crash, and I want to ask a different question about the first crash. You know, when you type G, there was what is known today as a buffer overflow error, and the machine crashed, and you had to fix that problem, and you started over again. What struck me when I learned about it for the first time is that buffer overflow errors have continued to plague the design of computer systems ever since. And in fact, you might say they're one of the real vulnerabilities in the design of modern computing. What I don't understand is, you know, when Robert Tappan Morris, for example, brought the internet to its knees in 1988, the then young internet, he used a buffer overflow error. Why didn't the designers...
Because
I can answer that.
Okay.
It's because they didn't talk to me.
right.
Well,
It was,
walk us through that.
no, it's stupid mistakes.
There are sort of two answers to this. One of them is that the initial specification for the first connection was that all messages would be 1 character in length. And because of the way that the 940 time-sharing system worked, when you typed a character on your terminal, it didn't appear on your terminal. It went to the computer, and the computer then sent back that character. That's called full duplex. And the 940 had what they call command recognition. So as you were logging in, as soon as it realized what you wanted to say, it would send back the rest of the command. So when you typed an L, you got an L, an O, you got an O, and a G, you got GIN. Well, that's 3 characters. And there was no memory available. And memory was very, very tight in the 940. And so when I was allocating buffers and things like that for output, I allocated 1 character because that's what the spec said. And 3 came along and there was a buffer overflow. Now, that seems to absolve me, but the problem is I wrote the spec.
So what you don't know about Bill is he also wrote both the first assembler and the first compiler for the Macintosh, and has gotten very little credit for that, but you're probably using some of his code somewhere.
No, thank you.
So, Len, tell us the story of how you came to put together the networking group that actually sort of did this on your end.
Well, I came to UCLA having this theory in my hands, waiting for it to have it implemented. Finally, as I said, ARPA said, let's build a network. So I had to get this group together. As Charlie said, he was working with Jerry Estrin. Jerry Estrin had put together a group of great programmers doing a variety of things. When we got the contract, the whole group moved over to me to jump on this really exciting project. So that's how this group entered the picture, and they continued to run with it beautifully.
So what about the design ideas? Packet switching seems to be kind of a non-obvious idea. And what was the networking theoretical world like when you were starting this process, and why did you, what attracted you to packet switching?
So there was no world. At the time, nobody was thinking about data networking in a serious way. And all my classmates at MIT were working on information theory and coding theory, which Claude Shannon had solved fundamentally. And the problems that were left over were small and hard. And I was dragged in to do a PhD. I didn't want to. My supervisor said, you got to do it. So I said, if I'm going to do it, I want to do something with impact, and I want to get the best professor I know. So I spoke to Claude Shannon. You may not know his name, but he's a great man. He took me on, and I looked around, and I was surrounded by computers. And I said, one day they're going to have to talk to each other. And the telephone network was woefully inadequate. So I looked at this problem. Here's a new problem. If it can be solved, it will have impact. And I had an approach. I knew how to basically extract the essence of the system, which had to do with what we now call the sharing economy. It's called Airbnb. If you've got a room that's not being used, if you've got a communication channel that's not being used, let somebody else use it who needs it right now. That whole idea of dynamic resource sharing was a principle that I put into the theory. And the whole idea of the packet switching, I analyzed a case where you would chop messages into fixed-length things called packets and handle them one at a time. And that had some advantages. So that whole thing came together. I had done the analysis, did an optimization, and then stood around and extracted the principles as to why this thing works well. You know, most of the students these days don't bother to do that. You know, they get a result and okay, I'm done, instead of saying, what is it teaching me? And we extracted some principles like dynamic resource sharing was key, like big systems are better, wanted to study a large network, millions of nodes instead of tens of nodes, because then you get emergent properties you don't see in a small network. And looking at distributed algorithms, distributed control, and recognizing nobody's in control when you have a large network, but you can't get one node to be in control because there's too much traffic, too vulnerable, too much traffic going in and out. So distribute it. Once you distribute the control, nobody's in control. So will that work? So you had to prove it wouldn't collapse. You could chop pieces, it would still work. So those are the kinds of things we extracted. Came to UCLA with that, waiting to build it. The opportunity came along, as I said, and bang.
And it was a DARPA-funded opportunity? Is that what you're talking about?
ARPA-funded.
ARPA-funded
yes.
opportunity, right.
Yes.
So let me jump up a level, and there's, for many years, been a debate over whether ARPA was funded or in some way backed because of the design was about survivability in the event of a nuclear war. This is hotly controversial. Is it wrong?
Yes,
So
it is.
It's an urban myth, but there's some truth to it.
Okay. Lukasik apparently made that assertion.
Look, in the video that you saw, you could tell that Taylor and Roberts were trying to figure out how to share computing resources among about a dozen universities that were studying artificial intelligence and computer science for ARPA in the 1960s. They couldn't buy a new computer for every university every year. So they said, we're going to build a network and you're going to have to share. So the whole idea, and papers that Roberts and Barry Wester wrote were about resource sharing. Even though some of the early ideas of packet switching came from Paul Barron in a study that he did at Rand Corporation, and that was about building survivable networks for post-nuclear responses or post-nuclear scenarios. So we should not conflate those two things. Okay. The subsequent internet design, however, did go after this question of survivability in a post-nuclear environment, and we even tested that idea because we used the packet radio system and put radios in the Strategic Air Command aircraft, artificially broke up the ARPANET into pieces and then glued it back together using the TCP/IP protocols and packet radio. So there is truth to some of this, but it wasn't specific to ARPANET as much as it was to the subsequent.
You know, one,
Steve,
Yeah,
let's
let me,
Stephen
let
then-
me, so this is, as to say, is a sort of a persistent myth, and the question is to what extent there's truth there. And it's subtle because there's various layers. As Vince said, Bob Taylor and Larry Roberts are all focused on how do you build a system that would allow the computers to communicate, people to communicate, share resources. And the degree of survivability, quote unquote, had to do with just normal operation. I mean, parts are going to break, lines are going to go down, and so forth. When you talk about survivability in a much more stringent sense, you're in a different part of the design space. And it isn't just all or nothing, because the worst case, the one that attracts everybody's attention, is imagine nuclear holocaust, and nobody's ever really focused hard on that problem. And I'll come back to that in just a second, because I spent some time with Lukasik over the past couple of years having a discussion about that. But you also have, apropos of what Vint talked about, that you have stressful situations, particularly in the military, that are more stressful than ordinary daily operation, but less stressful than the Holocaust kind of, total catastrophe. And the kind of survivability and knitting the pieces back together again are important experiments there, but they still won't take you all the way to what do you do if, in the worst case. The other part of the story that I think is very important is this culture of initiative that you described played out in multiple layers. So you have the agency, ARPA, which later became known as DARPA, which was created after Sputnik. And inside, you had a division into various offices, and the office that was of concern to us was this Information Processing Techniques office. And there was quite a bit of delegation down to the offices and to the program managers, and more importantly, even to the researchers themselves, the principal investigators, to invent the projects. And so there was as much bottoms-up kind of operation and choice of topics and so forth as there was top-down. It was not a dictatorial thing like we're going to build. This is sort of different from saying we're going to put a man on the moon and everything gets organized to that one objective. It was much, much broader. So the problem that the director of the agency, there were a series of them, but Steve Lukasik was central for a period of time, has is how does he provide the support for all of these projects to go forward and justify that to the higher levels of authority in the Defense Department and Congress. So a conversation approximately like this took place. Lukasik says to Larry Roberts, well, could it solve the reconstitution problem? And allegedly the answer was, well, I suppose. And there's no paperwork on this, except that years later, Lukasik wrote why I signed the checks for the ARPANET. And included in there is a little reference to nuclear survivability. But Roberts, I pressed him on that a couple of years ago. I interviewed him, and he said, well, if I'd really been trying to solve that problem, we would have connected every imp to 4 other imps and so forth. So, and clearly down at the levels that we were working at, there was absolutely zero attention to that. We were working on the problem that affects us all today. How do you get people to talk to each other? How do you get the computers to talk to each other? How do you accommodate the differences among all these systems and get them so forth? And we were not at all focused on sort of the hardcore defense problem of the day.
Weren't
So
there
wait a
some...
minute. I'm sorry. I really feel compelled to jump in here because there are 2 different things that we're talking about. We've been talking about the ARPANET. That's what this big celebration is about on the first connection to the 2 hosts. But I really must insist, Steve, that when Bob Kahn and I started to work on the internet design, it was driven by the idea that we would use these technologies for command and control. It was very driven by exactly a military requirement. And that's why we ended up with satellites and mobile radio, as well as the original ARPANET. So I mean, I want to make sure that it is not misunderstood that the motivations behind the original TCP/IP work was somehow only to do with civilian applications, because frankly it wasn't.
Yeah, no, so this is the area where it takes some care in describing, because of course, the projects and the orientation that you're working on is very important. What I was trying to say is that that kind of application, the command and control and reconstitution in the case that you lose various pieces, is qualitatively different from trying to imagine a post-nuclear exchange environment in which
I accept that, although I will argue that we tried to test at least some ideas that would be needed in order to contribute to that solution, and that's why we did the artificial breakup of the ARPANET.
Yeah.
So you mentioned packet radio and wireless technology. In the early 70s, ARPA began to fund research in that direction. And clearly, one of the major applications was military. Soldiers in the field, tanks running around. So there was a shift in what was coming down as to where they saw the applications was the basic networking, the internet stuff that we were doing, the ARPANET, had no expectation of military application at all.
I'm also very interested in how this distributed architecture won the day. When I showed up as a young reporter in the early 1980s, IBM was pushing this idea of a token ring, and there were many centralized ideas around. Actually, before I get to that, all the computing you guys have talked about, IBM and AT&T generally don't show up in that community that you were building. They were kind of the dominant. Why was that?
Proprietary network. They were pushing it. If you had an SNA network, an IBM SNA network, you bought IBM equipment and you used their communication protocols.
But wasn't IBM and some of those large companies, weren't they also skeptical about the idea of this project? I mean, they didn't even bid on it, is that right?
They were not skeptical about networking because IBM had SNA, Digital had DECnet, HP had DS. They wanted to network their computers, but they wanted only their brands of computers to be interconnected, and the Defense Department didn't want to end up trapped in one particular brand of computer for purposes of networking, which is why the heterogeneous interconnection of different brands of computers, which was demonstrated on the ARPANET and then subsequently expanded to allow multiple packet switch networks to be interconnected, was important to the Defense Department.
There's multiple times here. If you look at 1972, for example, when the public unveiling of the ARPANET, a few people from AT&T came and looked at it and turned up their nose and walked away. You talk about later in the late 1970s, and then IBM and AT&T others are all pushing networking of their particular flavor, and then it took a while for it to settle
And if you
down.
go back to '68, when the IMP project was being, the RFP for the IMP was, AT&T and IBM both refused to bid. They both said, this is a waste of time, it won't work.
Yeah.
AT&T finally launched in 1983 their great network called Net 1000. 3 years later, they closed it down with $1 billion loss because they couldn't do it. The technology is not trivial, and they, stiff-armed it, never got it going.
Yeah. Let me throw in a couple of questions from the audience. At what point did you start to think about the social and other impacts of your research work, e.g. equity, inclusion, and business?
Well, I think the first demonstrations of email, which came in mid to late 1971 with Ray Tomlinson, demonstrated that. Very quickly after that.
So email was not on the ARPANET in the first 2 years.
No,
That's right.
Yeah.
No, it was a development that it was foreshadowed by the use of time-sharing systems for email among the participants on the time-sharing system. Tomlinson at Bull, Baranek, and Newman figured out that you could use file transfers to move messages from one machine to another. It only had to say which machine was it going to and for whom. So we used the only character on the keyboard that wasn't already used with other operating systems, the @ sign. That's why you have user @ host as the basic form for email. So as soon as email popped up and we all got excited about it, we started seeing mailing lists, and that's when I realized that there was a real social element to this. The first mailing list I remember was called Sci-Fi Lovers, because we used to argue over who were the best, science fiction writers. And the next one I remember from Stanford was called Yum Yum, and it was a restaurant review for the Palo Alto area. It's very clear that this technology had a social component.
Do you remember HumanNets?
Yes, I do.
Because that was what drew me to the early ARPANET, because there you had technologists talking about the impact of technology, which was a really interesting window into that
So
world.
there's another story. I'd visit my graduate students, mostly the theoretical guys, not the software developers. And I walked into their lab one day. Instead of doing research as I wanted them to, they were busy on the machines intensely on news groups.
Yeah.
Restaurants, hiking, astronomy. What are you doing? And, oh my God, this is hot. And it really caught on.
With social media. Bill?
Just on that, one of the things that just speaking of email, another kind of social impact was there was a project that was being done jointly between Xerox and Park and a part of Xerox in El Segundo, and it was being coordinated by email. This was pretty early. This was in the 70s, mid-70s. And the thing that became very obvious was that using email to coordinate a project shifted the power. The people that now had the power were not the people that presented well, that could talk well, that were big, but they were the people that could write well. And it was just an interesting, but subtle, but very interesting shift that was a direct result of, basically this distributed, the networking.
Yeah. Actually, just a funny aside, when Bill Gates came to visit the masthead of the New York Times in probably 1992, they said, "How do you run your company?" And he said, "Oh, I use email." And they ordered up what became a front page story about the impact of electronic mail. So we were a little late to that. Here's another question. How and why did the network name change from ARPANET to Internet? And if they could change the name Internet, now what would you call it? That's the perfect name, it seems to me.
Well, originally, we called it, the paper that Bob Kahn and I wrote said, a protocol for packet network intercommunication. Mm-hmm. And it took too long to say that, and so within a year or so, we used the term internet to refer to the multiple network thing. I don't know what I call it now. Probably a, no, I can't, there's some bad words that occur to me.
Here's another question from the audience. When did you realize that you are an essential part of the historical breakthrough? What did you feel at that time? How long did it take you guys to understand that this technology was going to have the impact that it has had on the world?
1988 for me.
There's another...
What was it about 1988 that made...
I walked into the Interop show, which Dan Lynch started. It was an exhibition. 50,000 people showed up to see internet technology, hardware, software, and everything else. And I was walking in with Eric Benamou, who was the then 3Com CEO. And the first thing we saw was a 2-story Cisco Systems, display. And I asked Eric, how much does these cost? And he said $250,000. That was in 1988. And my jaw dropped, and I said, my God, people think they're actually going to make money out of the internet. and at that point, I started thinking, how could the general public get access to it? Because up until that time, there was an appropriate use policy that said no commercial traffic on any of the government-sponsored backbones. So for me, anyway, that particular moment is what triggered my interest in trying to get internet into the hands of the general public by making it commercially viable so it would be self-supporting.
One last word. Steve, was there a moment where you understood it was going to have the impact on the world that it did?
It was pretty evident almost instantly to me that if you had a computer, you would want it connected to the other computers, and that in those days computers were big. That was a tiny computer by comparison. So universities and businesses and governments had computers. Personal computers didn't exist yet. But it was evident to me that basically we would want to have that every computer, if you owned it, you would want it to be connected to the network. And so it was just a question of how long it would take for that to happen. And I thought that was real important from a utility point of view, from a practicality point of view. My head was focused on different kinds of research, much more abstract kinds of things. And so I used to sneer that this networking stuff was only socially useful. It didn't have any real depth.
We're out of time. Join me in thanking our panel for changing the world.
Thank you.
Thanks,